2 grams of anhydrous sodium sulfate is mixed with 2 grams of calcium chloride dihydrate and 2 grams of calcium sulfate dihydrate are collected, what is the percent yield?
Percent yield. Okay. Do you guys remember how to find percent yield?
It's
Actual, something like that. Actual yield over theoretical yield times 100.
Actual.
Actual over theoretical times 100.
I was thinking about percent error, but this is the, what's it called again?
Percent yield.
Percent yield. Cool. So we got that. It doesn't tell us what the actual values are. We're going to have to calculate the theoretical. Okay, so yeah, I think you're right. So let's try and write this out. So sodium sulfate.
what was it? Na2 or something?
Um,
Na2?
oh yeah. Yeah, because it's in the first column. Good job. And then what else?
Plus calcium chloride dihydrate.
Dihydrate. So times 2.
And Cl2.
Cl. Yeah, you're right. You're on a roll. Okay. We know that we have 2 grams of this. I think so. And 2 grams of this. Is that right? Yeah, 2 grams of that dihydrate and 2 grams of calcium sulfate dihydrate are collected. Okay. And this one is 2 grams right here. Okay. And we want to know percent yield.
Do we have to?
So we want to figure out, it says that we got this one. This is the experimental value. I'm guessing.
Do we have to balance?
Yeah. Is it not balanced?
Oh, I don't know.
CaSO1 and I don't know what that is. That looks good. The Cl though, this is gonna make a salt, so it's gonna also come with a salt here. I'm gonna write it down here. Hopefully this is not too ugly. It's gonna be 2 NaCl.
Yeah.
Which they didn't even like say anything about that. But whatever. So I think we're good now. Now what we want to do is we want to figure out how much, given our equation, how much would actually, which one of these is the, well, none of them is limiting reactant here. But how much is supposed to be produced over here? Which it would have to be. Now let's try it. 2.0 NaSO4 grams, right? When you do the molar mass, go to moles, right? 1 mole NaSO4. So that would be
119.
119.
Yeah, 119.05.
0.05.
Oh, it's Na2 SO4.
Oh, sorry. Forgot to write 2. So you have to add a little bit more.
142.
142. 142. Okay, great. So we got that. Now what? So So we're going to divide this. We're going to find out how many moles there are compared here. That will tell us how many moles of everything there is. Then we can find out how, based on how many moles and the periodic table, we can find out how many grams that amount of moles weighs, right? Yeah. So basically, yeah, we're taking this in grams, going to moles, which we probably just could have took this into. Whatever. Okay, so right here.
It equals 0.014.
Moles of Na2SO4. Come down here. I'm going to do 0.014 moles of Na2SO4. We can use the molar ratio, right? Which is 1 to 1. As far as I'm concerned, we are balanced. Well, yeah. Looks good to me. So we're going down here. The 1 mole of CaSO4 is compared to 1 mole of Na2SO4. Cool. Now we're in this. Now what we want to do is we want to use the molar ratio, cancel out that, and get us to grams now. Which this is correct.
CaSO4.
Yeah. So we need to find out how many grams that is on the periodic table. Once we have that, we'll know how many grams theoretically we should get.
It's 136.14.
136.14, you said?
Yeah.
14 or 13?
14.
Oh, 14. Good. Cool. So now, when we do this, the math, this is actually CaSO4. We're going to get how many grams of the stuff we actually have. Well, theoretically, we should have, given what we've been given. What was it?
1.916.
1.916?
Yeah.
Nice.
Grams
CaSO4. Then we use this here equation. We have theoretically, that's weird. Well, right. I mean, at least according, I'm assuming that this, what was written was the experiment, right? That's what I'm assuming. And this is the theoretical value. Because theoretically, if you have 2 grams of each, that's what you should get as your product. So, it's going to be over 100 though.
104.